Let's say you're starting a new 3D printing business, or maybe you've been in business for a few years, but you're looking to really dial in your pricing. Pricing for a 3D printing can be a really nebulous and difficult thing to do. It's one of the most important things you could possibly take care of for your business, is to know how to properly price, but probably even more important is to understand your underlying costs for your business. You really want to make sure that you're not undercutting yourself or losing any money. And what we're going to do in this video series is to properly teach you how to price for various 3D printing technologies. And in this video, we're going to pay attention more closely towards FDM printing in either an ABS or a PLA material. So let's find out what we can learn about 3D printing with your particular types of machines and the materials to see what should you price. All right, so before we get started, here's a few housekeeping items. One of the first things that you'll want to do in watching this video is to open up another tab and open the MakerOS 3D printing pricing calculator. We'll have a link in the description and we'll have a little pop-up in the video somewhere around here. So when you go to this web page, you're going to be prompted towards this little interface here, and it'll ask you to submit for results and to enter your email address so we can send you a special code in order to show those results. So go ahead, pause the video right now and go ahead and enter your information in there. Otherwise, you can continue to watch this video and we'll go through the various steps and how to properly price for FDM 3D printing for a smaller 3D printing shop. So now that we got that out of the way, you looking at the calculator and we have this interface up here, there's a few things that we can kind of take a look at in this web page. Is that we have all these different parameters on the left side and the calculations being done on the right side. So let's provide a scenario here for a very particular type of business that's pretty common in the 3D printing additive manufacturing space. So this might resonate with you and it might kind of hit home for you. So let's say you're a 2 to 5 person 3D printing service and you might do laser cutting, injection molding, and small scale production with smaller CNC machines. And you have additive manufacturing as an ancillary service that you offer to your clients for either prototyping and for going for production end use parts. But with that kind of profile, we're going to understand what type of machine would a company like that need. So let's say they're producing small batch electronics enclosures that they might need a prototype in either a PLA or an ABS material, and what's really necessary to print those would be, a decently priced desktop machine would be totally fine. Something that would be, obviously sub $10,000 could get the job done pretty well. So with that profile, we're going to go into this calculator and we're going to use some of those input values for the price of the machine, of the material, density, and all those good things, and come to a determination at the end of what are our costs along with what should we price for this particular machine type and for the type of material. So let's get started. So when I have the interface up here, we have a few fields to start off with. So we have the purchase unit set automatically as kilogram. So if you're using a desktop machine, you're more than likely buying it by the kilogram, and we have different units here if you buy it in a different form. But let's say we're going to do this for PLA 3D printing filament. So if you're using a very typical type of material that you buy either on Amazon or from a reputable reseller, you're probably paying anywhere between $15 to $40 for a roll of PLA plastic that's either at 3mm or 1.75 millimeters. But the density typically for a PLA material is 1.24 grams per cubic centimeter. And these values are really important. So looking at this, we're going to get a total calculated cost per gram, which is about 3 cents per gram given $30 in 1.24 grams per cubic centimeter. So now with that understanding of what your cost per gram is in printing, we need to understand a few things about the machine. So some of our default values in here might be a little high for what you're running, but let's bring this down again to a sub $10,000 FDM machine. So if you're using something that's typically out there, I'm not going to name any brands during these videos just to kind of stay neutral. But if you're using a mid-grade prosumer level machine, you're probably anywhere between the $5,000 to $6,000 range. So let's go ahead and just put $5,000 here. And something that's kind of nebulous to some people is, what is the machine lifetime hours of that machine? And depending on which manufacturer you purchase your machine from, they should have some life testing data on this. So that will either be on the information brochure for the machine, or you might want to reach out to their support and ask them, how long can my machine run operationally? Or you can do a different calculation that basically says, I am going to have so many hours usage of this machine until it is either obsolete, or once I have to replace it, it breaks down, one of those few things. Because the number we input here is, again, the usage time of the machine, and we're calculating the depreciation based on usage. And what we're going to get is an understanding of the cost of the depreciation of the machine on an hourly basis. So typically for a machine, a desktop prosumer level FDM machine is probably going to have anywhere between 4,000 to 6,000 operational hours until you either have to replace the machine, it becomes obsolete, you buy a new one, or it breaks. So I'm going to go in the middle here and say 5,000. So we're going to get basically a $1 per hour of the depreciation cost. Now, another field in here is the maintenance and service costs per year. And this is a really important factor to look at, especially when you're looking at all the different labor that goes into maintaining the nozzles, the build plates, all the other things that are replaceable. And depending on who you buy it from, there are service plans out there that cover some of these consumables, and if you need to send in the machine, given whatever issues that you might have with it. So what's pretty typical for a machine that costs this much, a desktop prosumer level machine, you're going to be spending at least roughly 40 hours minimum per year on just maybe sheer maintenance of the machine. And all those little moments, think about in using the machine that you have that are spent cleaning the build plate, replacing blue painter's tape, glue, all the replacement nozzles, maybe things on the gantry, but also include the service fee on top of that. So I've seen service fees for machines like this that range anywhere between $500 a year all the way up to $1,000. So it's basically, maybe a little less than a quarter of the cost of the machine annually is typically what you'll spend on maintenance. And you can do your own calculation on this too. And I highly encourage you to kind of, play around with this number here and or, reference from the manufacturer what those service plans cost. So what I'm going to put here is I'll do somewhere in the middle of the road and go roughly $850 per year on the maintenance and service costs per year, because we're going to assume that we have a $500 a year maintenance plan along with all the other extra consumables and my personal time that's going into maintaining that machine. So with that in mind, we have the depreciation cost per hour and we have the maintenance cost per hour, which equals an additional $1.44 per hour. Now, one of the more important parts of this entire calculator, is specifically for FDM, is calculating basically how long it takes to fabricate 1 cubic centimeter worth of material. So again, 1 cubic centimeter of material is 1.24 grams of PLA material, right? So it's 1.24 grams per cubic centimeter, and there you go. So a way to test this is a few different ways. And we'll go in depth more in a future video that dives into different slicer settings and different types of geometry. But for the sake of simplicity for this video, we're going to assume that we're only printing a small 1 cubic centimeter cube. So the way to do this is one of two different ways to calculate how quick your machine can print with this. One is that you simply just slice it and take the output value and enter it in here. Or the second, which is much more accurate, is to actually take your phone or a stopwatch and basically time it from the very moment that the machine starts laying down material to the moment that the machine completes the actual print itself. So given our knowledge of our machine type and the material that it's printing, and let's say we're printing at an average speed of anywhere between 60 to 80 millimeters per second with our machine with a 0.4 millimeter nozzle, you're probably going to get anywhere between 5 to 7 minutes to complete that 1 cubic centimeter cube. So we'll use that as an initial value. But again, keep in mind, this value will basically be very different with different types of geometry, different firmwares, different nozzle diameters, and so on. But again, we will cover that in a future video. So for this value, I'm going to enter 7 minutes to complete that cube. So what that means is that we're going to get what is called our material deposition rate. So material deposition rate is how much material we're laying down per hour, which basically means that it's 10.63 grams per hour. And our cost for that, so if it's 10.63 grams per hour multiplied by the cost of the material, that's 32 cents. Next, we're going to look at facility costs. So again, we're a 2 to 5 person shop, and we're in a decently sized city of 3 million or less people in the United States. There's a few of those, and you're paying maybe $1 per square foot on a monthly basis. So let's go ahead and just assume that we're paying about $2,500 for that office, and let's say our utilities are roughly, we'll say, $600 for utilities monthly for, let's say we got fiber internet, where our heating and cooling, our electricity costs, and so on and so forth. So that brings us to a facility cost of $4.31 per hour. Next, we have to look at the actual human cost. So this is a really important factor here, is you are a few person shop, and you might have actually 1 dedicated or 2 dedicated people to running the machines. But for this one particular machine, let's say you have 1 person that is actually doing all of the slicing, all the file prep, and running the machine itself, taking the part off the machine, taking out the support material, and bagging it up, sanding, and doing all the post-processing. So what I know about this whole process is that you are typically going to pay somebody at market rate for an application engineer or for somebody who's going to run these machines, part of this business, anywhere between $20 to $40 per hour to do that sort of task. However, if you are the business owner that is doing this, calculate your actual worth out there in the market. If you were to go out and find a job and understand what your true value is out there, of what you would charge normally on an hourly basis, or what the cost is out to your business paying yourself. So I'm going to go ahead and just leave this at $40 an hour. Highly encourage you to play around with this number, of course. But let's say that this time that's going to take to slice, prep, put either the SD card or basically stream the file to the machine and taking the parts off and everything will take about 30 minutes of actual human time to set up the machine. So what that means is that 40 bucks per hour, 30 minutes at $20 is going to be the cost per setup and teardown of the machine itself. So next we have to look at the software and services. So if you're running a very typical solid modeling type of program where you have to pay per seat on an annual license, you're probably using one of the more popular ones out there that's roughly 4,000 bucks as an annual license per seat. And there's other ones out there, of course, that are free, that are cloud-based and have lots of other different types of features. But make sure you enter in all those software costs that are basically attached to and/or in support of the 3D printing service that you're offering. So let's say we have, maybe our slicer is, let's go ahead and maybe it's $200 annually. If you have, one of the more popular ones that are out there for a machine like this, or maybe your machine comes with one out of the box from the manufacturer itself. So maybe you're not actually spending anything on the slicer. And let's say, for the CAM and/or ERP system, that would basically be the system that you're using for either, managing your inventory and your CRM system to manage your clients. What does that cost annually? Now, for the next one, for all other services, this is actually where you want to calculate your web hosting fees, your email service provider, and anything else that goes into the support of the business to help you run those machines ultimately. Also, a quick plug about us at MakerOS, you'll want to consider what would it take, and you will definitely see a big impact for all the different types of softwares that we can replace in this cost estimate right here for your cost per hour. So if you were on our Pro plan on a monthly basis, you'd be a little under $1,200 per year for your business. So that includes the autoquoter, obviously you'll have access to the pricing calculator, full project management, billing, and full client collaboration for the whole design, prototype, and production process for your clients. So enough about us, let's get back to the calculator. So with all these different software and services, we can see that we have a total cost per hour at $3.17. So we did material, machine, fabricated material, facility, human cost, and software and services. Now let's find out what our actual calculated costs are. So what we find out is our actual total hourly costs are about $9.24. And you might be surprised by this, because you might have, multi-hour prints, that in that type of machine, you might be pulling 12, sometimes 18. And in some cases, you might be pulling, 48, 72-hour prints. So that cost can add up pretty quickly into what's being, cost onto your business and other things that you can be doing. And we should be able to price appropriately for that in considering our margins. So our next step here is to figure out what does it actually cost to 3D print 1 full kilogram of material, considering our time cost, machine, and depreciation, and everything else included. So let's look at that for a moment. So before I get into this section here, let's look at, okay, there are 1,000 grams in a kilogram, of course. So based on our number here, saying that it's going to, our deposition rate is 10.63 grams per hour, we can say definitively that it'll basically take roughly 94 hours to fabricate 1 full kilogram of material, given our print speeds, profile, and everything else, and based on this number of printing a 1 cubic centimeter object within 7 minutes. So that actually means that that kilogram of material on an hourly basis is costing you $869 to fabricate that material. And a lot of people are surprised by this. When you kind of add up, what does that spool actually cost you, or what is that worth to your business? That's where we're deriving this, total cost, and what you should probably and most certainly, cover those costs, add a margin, and all those other additional values that you're adding for your customers. But next step in this process to figure out how many jobs can you actually print using that material. So a good way to do this is to look at your 10 most recent print projects or print jobs, and you can basically calculate the amount of material that you produced, and then you can say, okay, if each one of those 10 prints was about, let's say, 100 grams worth of material, then you would do 1,000 divided by 100 and 10 jobs. So let's say that there are 10 jobs basically in that spool of material, that 1 kilogram, which means there's an additional human cost of $200 because, again, every single time we're slicing, prepping, and taking the build plate off the machine is costing us an additional $20 per print job for the person that you're paying for, or you yourself to compensate for your time and labor onto that project, the print job. So the actual true total cost is a little over $8,000, so at $1,069.37. So that's your cost. What should you charge? This is, before I reveal this field, this is something that I consult clients all the time on, and there's a lot of intrinsic values and a lot of subjective things that you can add on top of this. So you as a business owner, you provide high quality products to your customers. You are not just some one person out of their basement printing your business, 2 to 5 employees. You have good value, good consultation services. You're very, upfront with your customers, and you're able to solve their problems. And they're obviously coming to you for that added level of service. So with all those things in mind, let's keep that in the back of our head. So I'm going to put this to 0 for a second before we go there and just show you again, this field here that says retail price per unit. This is a field that you'll use in the MakerOS autoquoter to enter in what you should charge total for that full kilogram of material. So what that means is that the break-even cost is about $1.07 per gram, or $1.33 per cubic centimeter, or retail price per hour at $11.37. Now let's bake in our margin on here. What I have seen and what I kind of tell my clients quite a bit is I have seen, PLA printing on a machine like this go anywhere from $1.80 per cubic centimeter all the way up to $2.50 per cubic centimeter. And depending on any of the additional services that you offer or who your clients actually are, you can charge more, maybe less. Of course, if in this business profile, if they are serving the consumer electronic industry, building small electronic housings, you could probably charge, $2 to $2.30 per cubic centimeter. If they're heavy industrial, you could probably charge a little bit more. So with that in mind, let's just look at what it would be if we had an 80% margin on this. So that's pretty much in the money right there. So we're looking at $2.39 per cubic centimeter, which means that you're charging basically $20 per hour for printing services. And don't feel shy about this. I see way too many businesses completely undercutting themselves. And I've seen people that have run through this calculator before, entered very similar values that I'm showing you right now, and they're not even meeting their break-even costs, and they're completely unaware of it. And I wouldn't be surprised a lot of people watching this video might feel the same way. And that's okay, because there's a lot of different things that go into this, and you can get much more advanced. And if you ever want to have a one-on-one session with us, we can kind of help walk you through and do a free consultation service on how to properly dial these values in to be more specific for your business, especially if you're running a big print farm, different types of technologies, etc. But for this process and for this example, again, let's just assume that 80% margin. And let's look at what should you charge minimum for a 1 hour print. So in this calculation, we're going to look at our hourly costs and the additional cost of the $20 per hour, or the $20 per print job for the employee human cost. So if I expand this here, we're going to see that we have the total hourly cost, the human time, our margin of 80%. So that means minimum for a 1 hour print is $52.63. And of course, for much different types of geometries, for different types of machines that you're using, there are going to be many different pricing considerations that you want to look at dependent upon the input of the file. So again, here's another quick plug for MakerOS and why I think you should basically get on a call with me or one of our team members so that we can properly show you how to price for your FDM service. We'll take a look at the calculator and our autoquoter to basically look at objects that are maybe large in bounding box but small in print volume. Those typical architectural models, things that are like a corkscrew, compensating for support material costs, and all the other crazy different things that clients will throw at you. So I hope you learned something today. I hope this calculator will be a valuable tool for your business and for the community as a whole. You can basically consider this as a cost calculator for yourself, but also a pricing calculator in what you should properly price, given a certain project coming in your business for a particular client. So have a great day, and I hope you guys reach out to us with any questions or leave a comment below if you think any other parameters should be added and if you think there's any sort of expansion that we could add to this calculator. In the next video, we're going to go over SLA 3D printing for the same type of business profile, and we'll be going through all the other complexities that go into pricing for that process. Thanks for hanging in there with me, and I'll see you next time. Thank you.